I'm really interested in. I've been using Grails for quite a while, but the whole industry, I think, is changing in a lot of ways. So this talk is kind of around asynchronous processing and what does Grails do in that space, and some of our web applications and how that's changed. So I call this Grails and Async, or Asynchronous Grails, Grails and Eventing. I mean, there's a lot of different words that we use to express this concept. So yeah. Twitter handle there is Colin Harrington, so feel free to hit me up on Twitter. I'm a senior consultant at Object Partners. It's a consultancy in Minneapolis. We do consulting around Java, Spring, Groovy, and Grails, and mobile. So some more contact info if you're interested, personal blog, that type of stuff. So a lot of this stuff's on the meetup page anyway, so yeah. So I've been focusing on doing early stage startups for the last 4 years. And I've had the opportunity to do a lot of Grails work and focus on that specific technology and mentor teams and help startups get up their first and second iteration. So before going too much further, I want to kind of talk about the history of where we are today and put some context in where we are. So back in the early days of the web, you only had HTML documents. You went to a web page, it was just a document, and yay, you could read it. And that was way better than the before that days when you had to use a specific system and know how to query things. And a Gopher protocol, anyone? That was actually invented in Minnesota, right? Minnesota Gophers? Yeah. So just straight up documents. HTML documents. That's where we started. And then we introduced the concept of hypermedia, right? Your HTML document could reference an image, and that image would load. And in the early days of the web, that was a big deal. You know, you're not just browsing in a text-based format. You now have a visual component to that. So that's kind of what I'm going to call phase one. The next phase is what I'm going to call Web 2, Web 2.0. There's lots of nomenclature on the web about Web 2.0. What that means, you know, dynamic applications. When you click on something, it hides, or little animations, or you know, your application is more rich. We went from an HTML document to something dynamic. We responded to a user clicking or hovering over things, or you know, that type of thing. Yay, JavaScript. This is where JavaScript went from being unknown to now we have to do this stuff in JavaScript because it's there in the browser, and that's the lingua franca of the web. A couple years go by, and we figure out, I don't just want to be able to interact dynamically with the page. I also want to get data remotely without doing a full page refresh. I want to get data resources as well. So the whole Ajax revolution of asynchronous JavaScript and XML. Well, it's asynchronous. It's actually ECMAScript. And we don't really do very much XML over that anymore. But you know, it's still asynchronous, right? So the XML HTTP request, the XHR, right? That was a big deal. Now you could do, instead of getting big pages, you can do fragments of a page, and you can say, oh, let me update this form and submit just this part of the page, and then use JavaScript and edit the DOM and play with that page. So it's a little more dynamic, right? Fast forward a little bit to where we're at now, where the HTML5 spec is continuously improving. You've got more browser support for some of these items, and even in IE10, you have even more support for some of the HTML5, CSS3, you know, the canvas tag, the video tag. Those are all things that we're saying, yeah, this is good. What's out is Flash and browser plugins, applets. And who heard about that malware issue on Mac? Did anyone have that? No one was affected? Does anyone know what was the attack vector? The Java plugin in the browser. So this browser plugin and the bridge that the browser has to do to interact with that can cause subtle issues, or there can be subtle bugs there that can allow malware to be installed on your system. So as a community, we're moving away from browser plugins and trying to replace them with native elements. A canvas element rather than a Flash ad. A video rather than the Flash player, right, being embedded as a browser plugin, playing a video. So that's kind of where we're going. It's all native, it's all built in, and it's all spec'd out, and it's considered safe until we, find something about it. So we have now what I call the return of the rich client. We now have all these things that you could only do in Flash or, like in an applet, now entering the browser space via HTML5. And along with that, we have a set of rich JavaScript frameworks. Sencha Touch, or Sencha, is one of them. It's a component-oriented model. Does anyone remember EXT.js? So that the company behind that actually is behind Sencha. So it's kind of the next iteration that is that has touch events and new user interface componentry. It's a little much better than it was in the early days of EXT.js. Then you have other tools like Ember and Backbone.js and Spine.js. You have these rich JavaScript frameworks that are living in the browser, as opposed to these rich taglib stuff that's on the server, right? So we see this is the return of the rich client. We're putting more into the client. So in this new world, we've got a lot of componentry in the browser. You got models, your JSON objects that represent the data behind your page. You got views. Some frameworks have the idea of UI components, right? Then you could have events that bubble up and down, and when you click on something, it goes all over the place. And data events, if you're familiar with Swing, the property change support, we have some of that in a component-oriented JavaScript framework. You have the concept of routes and history. So HTML5 push state allows JavaScript to update the URL on a site. So you can actually load one document, load a JavaScript application, and then make it look like you're navigating all over the place, but when in reality, it's only one application. The concepts of MVC or MVVC or whatever paradigm you're talking about there are showing up more and more in some of these JavaScript frameworks. Other eventing systems using local storage, cache manifests. The story in the client is way better than just, it runs a little bit of JavaScript now, very clearly. So this is the new world that we live in. So why asynchronous? Why event-driven systems? I think there's a critical shift that's happening in our field, in our area, in the space of software. And one of the reasons for that is we've entered a world of many core computing. Back in the day when I got my first Pentium computer, oh my gosh, it was awesome. It was fast, it was 75 megahertz, and I could overclock it to 90, and that was amazing. So we've gone from those days, and before that, the 386, 486, 686, to the Pentium 2, the Celeron stuff, the Pentium 3, the Pentium 4 with hyperthreading, right? So you've got two false threads that kind of keep the pipeline of the CPU busy, so you get more performance out of it, right? So then we go from those days to now the dual core days. So now you actually have two processors embedded in one, and they can talk to each other and whatnot, and very fast, very low latency. We've gone from dual core to quad core laptops, right? The i7 laptops right now. You can get a laptop right now that has 4 cores in it, that's hyper-threaded, so the operating system sees 8 different CPU cores in it. Server stuff, hexacore systems, dual processor hexacore systems where you have 12 cores. We have servers that are like that. And it's only going further. We're going to see 10-core systems, and we've stopped counting by cores at this point. You say dual core, quad core, hexacore, octa-core. What happens when you get to 50? Sequin 10? No, that doesn't work. So Intel has dubbed this many-core computing. So I think we're going to have to reinvent the way that we do our applications now to take advantage of this. We don't have one processor pipelining one set of instructions and making that serial process faster. We've got lots of little things happening and interacting with another asynchronously and dealing with events and data flows and that whole thing. So I think our whole field is changing at this point. So we have to be on top of this and embrace parallelization. On the server, it does matter, but it doesn't matter as much because you typically have a ton of requests thrown at a server. So you're processing, like if you have 100 people on a website, you're processing 100 requests a second. That's reasonable, and it's already parallel. But we're finding now that we want one request to have parallel nature. If you've got a big data set, you want to get that request out the door sooner rather than later. And the problem with big data doesn't work in a serial world. Current ways of doing things are procedural. We were talking earlier about the bubble sort algorithm, CS 101. What is that? It's a linear set of instructions. You do this, then you do that, then you compare, and then you do something else. That's going to change now that we have multiple cores and we can process that with 5 different threads, 8 different threads at once. And I think that is only going to increase. So this is definitely an area of computing to watch and keep your eye on because things are going to change really quickly. Another component that has changed the landscape as we know it is Node.js. So back in the day when web application frameworks were a pain in the butt to set up, and you had to spend forever configuring all sorts of little XML files and adjusting and tweaking things just to get one page working. Ruby on Rails came along and said, hey, convention over configuration, let's cut out all this extra crap and get to what we actually want to do. I feel like, and other people in the community feel like Node.js is the banter and force that was behind Ruby on Rails has been behind Node.js now, and it's turned a lot of things on its head. Like you said, it's actually the Chrome V8 engine. So the JavaScript engine that's in the Chrome browser, they made that so that it could run outside of the browser. And then a project came along and took that and created a server stack based on that. There's a couple things that are really interesting about that. And one of the movements in Node is non-blocking I/O, right? Most of our Java applications now, when you go do a SQL query, what does the application do? It runs your code, and then it generates and prepares the SQL statement, and then it fires that SQL statement off to your database server and sits and waits, and sits and waits, and sits and waits. So you've got a blocked, you're waiting, you're blocked on that I/O. You're waiting for the database to return some result so that you can do something. Well, Node.js and JavaScript is changing the way we do things. So instead of saying, give me, give me this data set, you'll say, here, get me this data set, and here's my number. Call me back when you got it, and then I'm free to, be done and go do something else, right? Node.js, and because JavaScript is on the server, that's the way you do things in JavaScript. You create callbacks, and that's how you orchestrate things. So we've got an extreme movement to non-blocking I/O there. So hopefully we'll see more libraries in the Java world take advantage of this paradigm and these orchestration principles. So in the Java world, we still do have a rich set of tools. I mean, you don't have to jump ship to go to like a Node.js. Because honestly, if you do that, you're going to have to reinvent all the problems we already solved in our Java world. You know what I mean? Security, authentication, authorization, HTTP, content negotiation, character encoding. I mean, there's a ton of stuff that's solved for you out of the box by using a known stack. So these are some of the tools that we're looking at now that are out there that we can leverage. So the functional concepts that you get out of a language like Lisp are important to learn and pick up. And we find Lisp and Scala and functional concepts introducing themselves into Groovy. So we have the concept of currying and left currying and right currying, and we now have gpars to execute things asynchronously. Scala is another functional language that'll help us in that state. We've got some new patterns, actors, and closures, and futures, and a whole bunch of functional concepts. So these are the things that are going to help us or launch us into this new world of asynchronous processing. So you think when you think about asynchronous eventing systems, there's not too many systems out there that couldn't withstand some asynchronous work. If you think about financial institutions, does anyone use mint.com? Right? So when you log into Mint, what happens? It updates your bank statements, right? Or it goes and synchronizes some stuff in the back end, and you see a little spinning icon that it's updating this bank's and that bank thing, bank account. If that wasn't asynchronous, you didn't get asynchronous events, you'd have to log onto mint.com, hit enter, and then wait for every single bank to get updated and update every transaction. They take forever. And do that serially, one after another? No. You want it parallelized, you want it fed out to a server farm, and you want each one to handle updating themselves. You want the page that you requested to come right back to you and let you know when the data behind on the server has been updated, right? We talk about devices. There's this whole world of Arduinos and hardware integrated systems that we can now hook into sensors, or when somebody walks through a door or something, or a sensor gets tripped, you can fire off an event and trigger a whole bunch of data stuff with that. Gaming, social, chat, hardware integration, medical, all of these fields, and just about every field you can think of can benefit from some form of asynchronous processing, where you return early and emit events and consume events. So apps are no longer one-sided. It's no longer you run the app and it does one thing in order at a time. It's split out into many cores, and you have different events coming in from different areas, and sometimes they're aggregated together, where two events together mean something. We use this all the time, not knowing it. I mean, you ever get a text message? That's an event right there. That's something pushed onto your phone, a badge notification, SMS. We do that all the time. Ding, boom, you have a message. So they're no longer one-sided. Apps in this world are interactive, dynamic, they're real-time and collaborative. So that's where we have some issues. Is real-time collaboration is hard when you're talking about data. If I've got a document that I'm editing live and somebody else goes and edits it, we have to know about the changes going back and forth, right? So otherwise, we're going to have version A and version B, and then you're going to have a merge problem then. right? If you can manage those, via some inventing system or collaborate and get the latest updates, if somebody deleted something that you're looking at, you want to know about that sooner rather than later. So this new world is it's fun. Not new either, but so this next section I'm going to kind of talk about the browser and applications in the browser. And then we'll jump back into seeing some of the stuff on the server side of what tools we have there for asynchronous processing. It's getting kind of warm in here. It's almost like I almost want to take a nap. No. So in the browser, HTTP is resource oriented. So do you kind of get the concept of that? So if you've studied REST, you understand that when a client makes a request to the server, it's asking the server for a resource, right? That's the whole nomenclature of HTTP, is a client makes a request to the server, and that request looks kind of like this. It's making a GET request. It's requesting the /index resource over the HTTP 1.1 protocol, and then there's another host header involved, right? So HTTP is resource oriented. Get me this resource, and then the server does what? The server's job is to send that response, right? So the server received that response, and now it's got to locate that resource and send that resource over to the client. This happens so fast nowadays, we don't even think about it, right? Our servers are so well optimized that by the time you hit enter, it's boom, boom, It's evaluated the domain name, figured out where it was, went through all the security, firewall, over the network, there and back again, found the resource and back again, just like that. Milliseconds of time. It's kind of amazing, actually. So this is an example of what a response looks like, HTTP 1.1, the protocol again, it's a 200. Yay, it's successful. Okay, and then we've got a bunch of headers, the date, the last modified, e-tags. We get some content negotiation stuff in here. That's the HTTP protocol overhead. And then after it's done with that section, then it gets into streaming the actual resource that you requested. And for most pages, it's an HTML document that you're looking at. Ajax, it would be a JSON object, or you're generating XML, or I don't know, a binary PDF, a binary something or other, image, whatever. So typically, you get returned an HTML document with Hypermedia, right? It returns the content of the HTML, the string data, right? So embedded in that string data are images. There's this concept called hypermedia that then when the browser detects, oh, they've got an image tag, let me slurp up that source and go request that from the server. So it has to make another request for all the images that are on the page. All your CSS files are on the page. All your JavaScript files are on your page. Each one of those are resources that it's asking for. So that's part of how HTTP works. You load the initial document, and then you figure out what the sub-pieces are that you have to load, and then you load each one of them. So quite literally, a normal web page that's not very well optimized could induce hundreds of HTTP requests just in one web page. If you've got lots of images, or you got little button images, CSS files are all over the place, JavaScript, fragments, all sorts of stuff. So just a little tangent. Google released a couple days ago mod Speedy, so an Apache module. Does anyone know what Speedy is? SPDY. So Speedy is another protocol. It's to replace HTTP or to improve on HTTP. So Speedy says, instead of sending just the HTML document down and then letting the browser request all the other objects, Speedy says, I'm giving you this document. I know there's like 20 different resources that you need. I'm just going to keep chucking it down to you until you have everything. So that's a huge performance gain. because most of the time is not taken in actually, we've got some pretty high bandwidth network connections. Most of the time that we deal with is not actually data transfer, it's actually the latency over the network, of requesting. You request one, and then one resource, and then you have to request another one, and that one has another resource embedded in it, and then you have to request that one, and it just 50 milliseconds at a time add up. So what happens when we want to receive events from the server, right? HTTP, there's no mechanism for the server to call you back, right? It's all based in the client. The client makes the request for a resource, and then the server responds. So the server's in a responding state. So there's no concept of the server giving you some data back, right? Calling you back. There's no, that just doesn't exist. So there's a bunch of different hacks. I'm not going to call them totally hacks, but there are a bunch of different patterns and access methods that people look to that are pretty logical to start going down to try and receive events from the server, right? And the event could be is something like on Facebook, that you have a message, a Facebook notification or a Facebook message, or it could be like you're on your Gmail client and you're a mail client and you want to be notified when you get a new email. So how do you do that? Well, the first attempt that most people do is just ask the server every so many seconds, If I want to know if there are any new emails, I'm going to say, okay, server, do you have any new emails for me? Nope, okay. Wait for, so many seconds. Hey, server, do you have any new emails for me? Nope. How about now? Nope. Reminds me of my kids when we're in the car. Are we there yet? Nope. Are we there yet? Nope. Are we there yet? Nope. Are we there yet? Yes. Just kidding. No. So that's painful. I don't know if you've ever gone through that cycle. It's painful. It's a lot of extra talking, and it's a lot of extra noise. And I just don't want to talk that much and answer that question again. It hasn't changed. I'll let you know. So polling doesn't scale. It's lots of overhead. There's lots of extra traffic on the network. HTTP requests going out and the response coming back. And then so many seconds later, the same thing again, just for no response. The client has to have some processing to have some JavaScript that says, set a timeout for 30 seconds and then ask the server again. So it has to actually initiate the request. It has to get the response from that. And then it has to determine what to do with that response, if it's A or B, and then it has to schedule another check. So it's extra work that has to happen. It's extra processing that it's not necessary. The server has extra work it has to do. If you're asking the server, are there any new email messages? You're typically probably going and looking at a table in a database and doing a database query. So it's very possible that this request is expensive on the server, right? So there's extra work to be done in there in the server. So just consider this. If you polled a server every 10 seconds, just a small little ping, anything new, yes or no, every 10 seconds for 5 minutes, that would be 30 requests. Doesn't sound too bad. I mean, 30 requests, you can handle that. We got some big servers. Throw more RAM at it, right? Well, the problem is once you get to, what happens when you get 100 clients or 100,000? It doesn't scale at all. Unfortunately, a lot of people have implemented their applications to do this, and this is kind of a poor man's eventing system from the server. So there are plugins like the jQuery periodical updater. Has anyone used that one? So you basically specify a timeout, and it does some of this stuff for you. It actually is configurable where you can configure a delay. So you can say, ask every 5 seconds, and then by the time you get to like 2 minutes out, forget it. Let's just ask every 5 minutes. so it'll decay over time and change the timeout window. Another stab at this. There's got to be a better way to do this, and there are. And the next logical iteration is to do something called long polling, right? This is also known as Comet. Comet's kind of an umbrella term that kind of covers a number of different patterns and intricacies in how this is done. So keep that in mind. There are different ways to do this. So the concept with long polling, it's different than polling every 5 seconds. In polling every 5 seconds, you make a request and the server responds as soon as it can. In long polling, you make a request with a ridiculous timeout window on it. So you make one request to the server and the server does nothing with it. It just holds it, keeps it open somehow, and let that request sit there, right? Until there is an event. And when there is an event, then it says, okay, fine, I got something. And then gives a response to back to the client. That's helpful. That's way better. I mean, you don't have all this, are we there yet? Are we there yet? Are we there yet? No. I'll tell you when we are. You ask that question in the air, I'll answer it when we actually get there. So that's way better, way less network traffic, but there's still some issues with this. Comet. Comet is reverse Ajax, right? So Ajax, the common cleaning product, Comet, another cleaning product. Yay, sweet. So I wanted to go back to here. So this is limited here too because you have this window where the event is sent down to the client, and there's another it has to long poll and poll again. So if an event comes in this window right here, in between A and B, then you're going to wait until the client has processed it and then reconnected the long polling. It had polled again, right? So you kind of have this window. Another issue with this is it's only half duplex. Only one person can talk at a time. You can either request data or you can receive data. You can't do both at once, right? Besides that, it's an abuse of HTTP. It really is. It's a little hack to, oh man. Normally when you ask a server to get a resource, it responds to you. And there are status codes to tell you if it's not ready or if it's not understood. And the initial spec was all about responding immediately. There wasn't a concept of just holding that request open until there was something. It was always the client's responsibility to do something like that. So, and there are consequences to that, which we'll see in a little bit. The next logical step beyond that is, okay, let's eliminate that window, right? So back here, we had this nice little window where if there was another event here, that you'd miss it or it would lag until the long polling had responded, right? So doesn't seem too bad, but realistically, when you talk about certain types of eventing systems, you often have multiple events at once, right? If you have, if somebody sends out some notifications, you often get clusters of notifications. And this event might only be the event for the first one. So you only receive the first one, and there are 10 other ones sitting there for you that you're not going to get until you reconnect. And there's that lag time, which is perceivable, though. If you're doing some real-time drawing application or something like Google Docs where it updates immediately exactly when it happens, you'll notice if there's a second lag there. Another thing that this has an issue with is it keeps a request from the client open to the server. And most browsers have a limitation of an on-purpose limitation of only being able to have 2 open requests to a given server, right? So you don't overload a server. It's 2 at a time. So if you're taking up one, that only leaves you another lane to get data. So if you do this in 2 different places, you're blocked. You can't get any more data, right? That's a problem. You're using up resources there. The next step to eliminate this gap is to do something called HTTP streaming. Now this is where the client makes a request and the server never closes the connection. It responds how it normally should and just keeps sending data along. When it gets something, then it'll pop something new in there. So that something new could be a JavaScript tag that evaluates some JavaScript, right? And then you could see how you could kind of build a little framework to have the server run code in JavaScript in the browser by emitting new JavaScript tags that have stuff in it, right? So their event comes along, it fires it off, it's still open. But you still have the same issue that it's keeping a connection to the server open, and it's really not how this was meant to be. Beyond the concept of, there's lots and lots of HTTP protocol overhead. So when I'm requesting a resource, if I just want an event, I don't want to have to do like the headers there and back and content negotiation and all this extra stuff. You have some overhead. They're usually half duplex. Unlike polling, you do sometimes have keep alives, little pings to say, hey, are you still there? Close the connection if it's not. And keeps browser connections open. So there are way more issues than this, but that's just kind of like my top of the list. So that doesn't work. HTTP does not work for server-side events coming back to us. You have to do some really screwy stuff to get that to work. So in comes WebSockets. Dun, dun, dun. Yeah, right. It's not an actual socket in terms of a programming an open socket. It is a protocol, right? So we need a new protocol to get server-side events. We need something that's full duplex, that is persistent and open, that goes through proxies, that works over our networks, that whole thing. So HTML5 WebSockets. That's the answer at this point. So this is the API. It's all out there on w3.org. The actual interface, I didn't want to put the interface here, but it's actually, the interface through WebSocket is actually relatively small. There's a couple states, there's a little buffer amount, then there's some callbacks when it's open and closed. This is how you create a new WebSocket. You just call new WebSocket. And notice the new protocol, WS://. It's not HTTP, it's a new protocol. It's a WebSocket.
Is that on the client side or the server side?
This is client side.
Okay.
So this would be running in your browser.
Right. Yeah, that's the server. The server is the WebSocket.
So WebSocket is actually in the client.
I understand.
And
WebSockets.org would be the server that
yes,
you're trying to connect to.
yes, exactly. So this would be the endpoint or the resource that you would request. And there's a whole protocol around. It actually uses an HTTP request with an upgrade header, and the protocol is versioned. I mean, there's a lot of cool stuff in here. And it's really easy to use. So you set some callback functions on open, just alert, or you could imagine updating a status. Yay, I connected to the server if on open. On message. So that's how the server can send you messages, whatever that message is. If it's a string, if it's binary data, if it's, there's a couple different things that it can be in JavaScript. You can set an on-close function. There's an on-error function that you can hook up. So it's really helpful. It's event-driven. And then you just receive messages on message. And then your application would receive that event and rip out the data from that message, and that's it. Do whatever you want to. You're in the browser. It's your playland. So if you want to send something to the server, you just call send. When you're done, clean it up and call close, and then you're done. Simple. That's a really easy API. I mean, just about anyone who's done JavaScript can grok that and see how they could use that and hook that into different systems. So there's the WebSocket protocol is a protocol itself. It supports HTTP upgrading, right? So it'll go through the proxy and through the firewall, and it's a request that says, here, let me set up this WebSocket. You've got the just raw WebSocket and WebSocket Secure using SSL. You get the same paradigms that you have in the HTTP world. The neat thing about this is it's a version protocol. So there's a little bit of protocol negotiation. So if your browser supports version 13 and your server supports version 13, then the HTTP start of a WebSocket would say version 13, and then they would respond, so okay, yeah, great, version 13. Or it might say, no, let's try version 17 instead.
Application protocol or the WebSocket protocol?
The WebSocket protocol. So
nothing to do your application.
Correct. So there's the outer WebSocket protocol, which is just the outside your application, not any of your application data at all. But the beautiful thing is there's a little bit of content negotiation in figuring out the inner protocol that you're talking about, right? So what does that mean? I was working with a buddy on this lighting project, sending data to an Arduino over a serial connection. And you're literally just reading binary bits. And you have like your little stop bits, and you've got your special magic keys that denote a beginning of a message and an end of a message, and all of that stuff. So you have an inner protocol to WebSockets, and you can have that protocol be anything. You can optimize it. You can have it be compressed. You can do whatever you want to. The WebSocket is just a container to contain that other protocol. It could be as heavyweight or as lightweight as you want, and it's extensible that way. Yeah.
Is it still subject to the same origin policy?
The same what?
Same origin policy?
Yes, that's an interesting question. I think it's deeper than that. There's if you look at the spec, and there is some support for allowing non-same origin, but it's explicit in figuring out how to do that. Does that make sense? So I don't think you're 100% limited to same origin. Does that make sense? Yeah. Like if you load a page, like example.com, you can't open a WebSocket to google.com unless Google explicitly allows that. And I think there's something called CORS or something in my reading that vaguely reminds me of that question. So. There's like a cross-domain XML, setup that you can do very much like you do with, other systems. But it's not supported by all the browsers yet, not even an IE9. I think the caniuse.com has it at about like 46% of the browsers that are out there support it. 46% of the latest browsers that are out there support these versions. So it's not in every browser. That's a little bit of a problem, but it's helpful to know where we're going and that some browsers can. If you have the possibility of limiting what browsers your current users are using, like you're in a controlled environment where you own the hardware, and that's a valid point to have your users use the latest version of Chrome, or you require them to use the latest version of something. That's perfectly valid. Also, the server support of this in the Java world is kind of lagging. There's a JSR on this, and they're just now getting around to formalizing some of that. They kind of played a little bit of the wait and see. Last month, it's actually now supported in Tomcat 7027 and onwards. So there's a bug ticket with some details and commit logs and stuff on that out there. But that's just the standard containers, right? The standalone, you can launch your own standalone containers. There's about a bazillion Node.js WebSocket implementations, right? People playing with WebSocket and half-baked here and there, pieces. There's several Java and Python servers that you can, fire up that are not tied into the actual big containers that are they're standalone systems. So that might be viable to embed that in your application or run that alongside it as you launch a war in the Java world. I don't know. It's feasible to do WebSockets now, barring which clients you're actually going to support. So that will change. 2 years from now, that'll be a totally different story. So, does anyone still support IE6? IE what? Oh yeah, that's right. IE7's the new IE6, right? We all know that, right? So, 2012, great. I see WebSockets out there. You can play with it in your own sandbox, or if you've got a little, a controlled environment where you can control the browsers. It's effective to do. But what do you do now? Now you kind of have to compromise until we get there. So what does that mean? Maybe doing some long polling or HTTP streaming and living with the differences. I mean, your other options are, using Flash and using Flash sockets and Blaze DS. I don't know if anyone's used that on the server side. You can emit events and use the JavaScript bridge to contact, do all that. Silverlight duplex services. Silverlight's dead in the water, isn't it? Wasn't there the big, announcement on that mix or something? I don't know. But it's an option out there. Or a Java applet with a straight TCP or just a straight socket. Woohoo! Ooh, no. Maybe in an enterprise world, that might be a viable solution. You might choose to do that if no. Or the other option is to do graceful degradation, which I think is a better option at this point. You want to support those who can support real-time WebSocket events that are low latency, low protocol overhead. But those who can't, okay, well, their experience might be a little bit degraded, and they might have to deal with long polling and the issues inherent in that. So, one ring to rule them all. So in Grails, in the Java world, there's a framework called Atmosphere. So it's kind of a play on Comet, being close to Earth, and WebSockets, right? So this is an asynchronous WebSocket Comet framework, right? So I've got this little section right here. Do you guys know what this is? Do you guys use Grails at all? Who uses Grails in this room? All right. So the build config. This is a plugin dependency that you can put in your build config instead of putting in your application.properties to declare that dependency. Right? So that's how you would install it. You'd put that in build config. So Atmosphere has a server-side and a client-side component, right? And the purpose of this is to support graceful degradation. You want to be able to say, do you support WebSockets? Great, use WebSockets. Otherwise, use this other mechanism. And have your client-side and server-side componentry be pretty seamless and pretty healthy. So you can check out that plugin. And there's a Java project and a lot of support. Play and Akka, and there's a whole list of other frameworks that actually support Atmosphere as well. So if you choose to go use Atmosphere, there's a lot more support and a lot more people using it than just a one-off plugin. The other option you have is roll your own. That you can use CometD. That's another plugin. Again, how to install it. So CometD is a scalable HTTP event routing bus that uses Ajax push technology pattern known as Comet. So this is kind of a long polling mechanism. And on the server side, it uses like a by use service, and you send events to this service, and it keeps those commit requests and sends those events to the open clients, and it's a whole protocol there to do long polling. So if you were to use WebSockets, you could custom roll your own and say, hey, does this browser support WebSockets? Yes or no. If it does, great, use WebSockets. If it doesn't, then use CometD, and then just route your events through one mechanism or another. And it essentially would be the same, right? That's kind of what the Atmosphere plugin is doing for you. So good question on that. So currently in all of the major containers in Servlet 2.5, you have to have, there's custom support in every different container in a different way to support these asynchronous features, right? So Servlet 3.0 async is all about creating a consistent API so that you don't have to have differing implementations in Tomcat versus WebSphere versus, you know, you get the picture. And if you look at the Tomcat code, there is a lot of, if you walk through, there's a lot of, if you're commit, then do this, otherwise do that. You know, and that's a performance and I guess maybe not performance so much, but maintenance nightmare. As soon as you add another complexity layer, that creates, you know, more issues that you need to address, and that's easy to forget about that. So the Servlet 3.0 is all about fixing that and creating a common API. So most servers these days in the Java world use this thread per request model. You familiar with what that means? So every request that goes in, it is assigned a thread, and that request stays on that thread throughout your application, throughout, you know, the levels of Apache, Tomcat, connectors, and the low-level filters, and into your application and the filter chains, and routed through your application, through your controller logic, through your whatever persistence logic, view rendering, and out. So that one thread lives throughout that whole time, right? In HTTP streaming, it'd be thread per HTTP connection. So, yeah. So if you're doing something like Comet, where you're making a request, and you're not expecting a response for an unknown time frame, it could be 10 hours before you get a response. It could be never. So you're tying up a server resource there by that request. That one request is, you're tying up a thread. So if you have 1,000 people doing that, you can exhaust a thread pool really quickly and degrade, you know, your performance. There's a couple good blog posts out there about real-world performance where you can kind of you can hack and not hack, but change your how many threads are available in Tomcat to, you know, a reasonable number, so you can, you know, lower it to 10 or something, and then you can exhaust that thread pool and hit that upper threshold pretty easily. So if these long polling requests are tying up server threads or server resources, that's a problem. That is a potential bottleneck, and that turns out into less throughput. And through some tests, you can figure out that, you know, using the async start async, the asynchronous context, I think it's called, async context in Servlet 3.0, you can actually up your load by a factor of 10 or more, the load your server can handle. So what that does is the incoming thread pool can still handle and service the incoming requests and the fast stuff that happens, and then the slow requests, like generating a big report or a PDF or, you know, doing some data aggregation, all that stuff can happen on a background thread and not tie up the incoming requests, and not, you know, prevent people from coming to the door by standing in the doorway, basically. So threads have memory usage, and then you can get into like a thread starvation mode if you have too many of these going on. So there's a whole bunch of, you know, work into managing your app server if you to get the appropriate amount of threads running. If you front it with Apache to Tomcat, you're going to want to synchronize those at some level, and it's just extra stuff you have to think about. So with Servlet 3.0, this is only a big issue in terms of expensive tasks and long-running tasks. It's something like generating reports. Sometimes you have complex third-party integration, something like going and hitting a SOAP service at one third party and then going and coordinating with another third party, and all that can take time. In the example of Mint, imagine what they have to do if you've got 5 different bank accounts. They've got to go out to each and every one and then aggregate that data back. You wouldn't want that to happen inside an actual web request, right? Because that would be tying up server resources. You'd want that to be offloaded and let me know when it's done. Long polling, HTTP streaming, that type of stuff. Considered expensive, right? I was going to show an example of thread starvation, but we're running low on time and I'm running on his laptop, so I'm not going to do that right now. Basically, you can fire up Visual VM and use the mbean manager to modify the number of threads that Tomcat has available to you. And then you make requests to the server and they'll block and you'll be stuck for doing something like a long running task. Even just doing sleep, you're blocked. So let's go back into the Grails world. Servlet 3.0 and Grails is as simple as changing in your build config Grails servlet.version to 3.0. And then you have to deploy to a Servlet 3.0 container that supports Servlet 3.0. It's pretty simple. So here's an example of doing an asynchronous request in Grails. So this is in a controller, an index action in a controller. So what you do is you call this start async function, and that returns an async context, right? And then you call the start method on that and feed it a closure. So what that's going to do is take this closure and execute that in a new thread. It's going to let this return, the thread that the current request is coming in on, return and have this heavy stuff. Imagine this is something heavy like generating a PDF or something. Run on a new thread and then pipe that out when it's done. There's also support. In the first example, let me back up and explain that. In the first example, we are rendering a template right here in the controller. So it's actually going to render the actual character data to the response, right? And then it's going to complete the response. And you have to call complete, otherwise your thread will just be sitting there forever. Not good. So there's another mechanism called dispatch, which lets the view rendering dispatch in a new thread, right? So same pattern, start async, returns an asynchronous context, async context. That's Servlet 3.0 async context. You feed it, you have a start method and you feed it a closure. You do a bunch of work, your long running tasks. It might be integrating with services that do who knows what. Might be doing a full table scan of everything. Then you can render a view, and this will return, this will set the model in view, basically the Spring model in view, and dispatch will let the actual view rendering of Grails happen then, right? So here, all you're doing is specifying your view, that's it. And then you're letting the default Grails view rendering stuff happen in that new thread, right? With this dispatch, I don't believe you need that, because once it's done view rendering, I believe that's built into it. It knows whether it was async or not. And all right, let's get back to the server. Let's check out some other componentry on the server. So another tool we have is Spring application events. So that's what, this is what these look like. Your application context in Spring actually has a publish event function on it. Not many people realize Spring application events live there. So for the whole application context, you can publish an event. There's support for like multicasting to multiple contexts, and you can hook up some interesting multi-containers, events going back and forth. But yeah, and then here's an example of a My Application event. So you're publishing something that extends My Application event. It's actually an application event publisher, and the application context implements that or extends its interface to. So here's the actual event that you're publishing. So you've got My Application event that extends application event, and then then you can put other pieces of data on there. You can hook up different pieces, like and put different things in that application event. If you want to put a domain object, if you want to put a map, anything, you can definitely create your own event, pump it in there, and publish that event out. This is what it looks like to consume these events, right? It's a My Application event listener extends application listener. This is all a Spring concept, right? And you just have an on application event function and do your thing. Handle those events. There's a lot of componentry and stuff that's just there that we don't really know about because we're stuck in controller or service land or your database, or there's so much going on. I just want people to be aware of what's already there. Just out of the basic stack, you have a service context listener, right? When the application comes up and goes down, or HTTP session listener. There's other standard Spring events, and there's a bunch more in there actually tied to the creation of new requests, and other plugins emit their own events. So using these on the server side can be very helpful. You have singleton beans to subscribe to these. So servlet context listener. So when the context is created or destroyed, sometimes you need to do some stuff. Servlet context attribute listeners. So when you add or remove or change attributes. Same thing with sessions. When you create a new HTTP session or destroy one, depending on your policy with that. There's also attribute listeners there. If they update certain attributes, you may want to filter on that. If you have like a user credential session attribute, or not user credential, user ID or user account, tenant ID or whatever, you might want to listen to if that attribute has changed, then you might want to have to do some code there, and you have some valves here to now play with it. Spring Security emits events on successful login or failures. That's actually how it delegates, authentication challenges. When you request a resource, there's filters in front of it that throw, I forget the exact exception, but it's like a authentication required something or other exception. Something like that. If you are logged in and you don't have permission to access something, it'll throw a different exception. So there are a bunch of listeners that you can hook up there too. So keep in mind, in Grails you have lots of singleton beans. All your services by default are singleton. You can scope them differently. You can create one per session or one per request or whatever. You can make them prototypal, but you can attach application event listeners to these, and services might be a good place for that. Other beans that you might set up in resources.groovy, you might want to have associated with these different events and subscribe to different things. So, next thing I want to talk about is message queues. That's another pattern that's really essential in Grails these days. One of the first mistakes I see people make is in a service layer when you need to send an email. A user created an account. They hit submit and their account is created on the server, and then the mail plugin sends the email, and they're doing all this stuff in band, where a lot of that stuff should probably be done out of band. Should be done either in another JVM or somewhere else that's not inside the container of the request. A classic example that I've seen people use Quartz jobs and have one application and have their job run, like every 30 minutes and have that job consume a ton of memory and bring the whole application down. For a cron job, really? There's a bunch of patterns that you want to feed your stuff off to be handled in the background. So that's where message queues come in handy, and where I've used them a lot. Sending text messages, sending anything that requires I/O, dealing with other APIs that you might want to, if it fails, maybe retry it. So there's some support in that. There's some support in like adding future requests or adding something to a queue in 5 minutes or something to that effect. So a couple of the common ones: RabbitMQ, ActiveMQ. JSQL is really interesting. It's actually like Rescue. Was it LinkedIn? Did they create Rescue, or was it? Forget who it was. Anyway, it creates a queue out of Redis, which is a really fast NoSQL data store. So JSQL is kind of like the Java version of Rescue, right? So there's support for doing queues and like a little administration UI where you can retry jobs, and that's really handy if you use Redis already and you don't want to implement, a more heavyweight, JMS queue. And there's a bunch more queues. I don't really want to dive into all the queues of the world. So here's the JMS plugin. Here's again the same dependency line to add in your build config. Here's an example of using the JMS plugin to send a message. Destination, you have a message, and it sends that asynchronously. You can use a post processor to, like, if you need to add authentication or anything else. There's templating support. There's a lot of support in these plugins for configurability and authentication, and some of these things have been thought through. So you'll probably, when you're first implementing these, you won't run into issues that others haven't so far. So you specify the actual queue name, the message, what type of post processor, and some other stuff. There's a bunch of different ways. So I guess my point here is that there's a lot of flexibility here. So previously we sent a message to a queue, a named queue, right? Here we're sending a message as a topic. So to anyone who wants to subscribe to that topic will get that message, right? Here we're actually sending to a service. So this uses like appname.person is the queue name, right? So JMS plugin will use that by default. So if you've got like a person service, it'll be personservice.person would be the name of the queue. And then here's service.method, app name, person, which is the service, and then the method. That would be the queue name. So there's some paradigms around creating queues that are roughly associated with Grails services, and it ends up being just a naming convention. Here's another one where it'll send to the remote queue, remote app. So you could have one application publish events to another remote application, which is really handy if you want to offload. That's a pattern that I've implemented a number of times to offload sending of emails or offload messaging or dealing with APIs to another out of band, out of the public's eye service that can be up or down, and you can scale those out and have 20 different apps processing messages if you have a lot of them. So it allows you a lot of scalability there too. Okay, so that was the publishing side of the world. What about receiving messages? So this is what it looks like to receive a message. So with a JMS plugin, we use the static exposes over JMS. What that means is, person.onMessage, that queue, those messages will show up here and will actually execute this service method. Same here, you have some more configurations here. the actual destination, if it's a topic or not. You can create adapters. There's a lot of support in this plugin, so you'll find it's helpful. There's also the AST, or the annotation configuration. That's not an AST. So right here, it's subscribed to the name myQ, and the selector's name is not null, which means that if there is something on myQ where the name is null, it won't go through to add person, right? So you can create this selector. It's kind of a filter layer. Here we go. We have an actual subscriber. You're subscribing to just a topic. And then this will get, this will fire every time there's a new message on that queue. Okay, so that's queues, and they're really handy. And talking about scalability, you could do a whole deep dive on JMS and queues. So, next thing I want to go through is the executor plugin. This is the successor to the background thread plugin, right? So this is just going to run things in a background thread. You have a run async closure, and you pass it a closure. Actually, it takes a closure and it executes that closure asynchronously using this executor service. The call async actually returns, let's see, it actually returns a future back that you can work with later, right? So if you're familiar with the functional concepts of a future, that's really helpful. Only in 1.6, Java 1.6 and beyond. A few more things. This guy is gpars. Has anyone used gpars or know what it is? Jeepers. Jeepers creepers. Groovy Parallel Systems. It's actually built into Groovy now. It's pretty powerful. I'm not going to read the slide to you, but it helps you deal with concurrency and running like multiple threads at once. You have concurrent collections that you can run. You can run things in the background. There's a fork join abstraction. You have a data flow concurrency construct. You can set up multiple things where process this collection asynchronously, and that has to flow. That data has to then flow into this other programmatic thing. So there's a lot here. There's an actor programming model that you could use it as, agents, and there's also software transactional memory support in there. So there's a lot of tooling there. So if you get into any of that, or you run into problems where you need some of this, it's built into Groovy now. Next point, Quartz Scheduler. This is really handy for doing triggered tasks, cron jobs. You want to run a report at midnight, great. You want to run every 30 seconds, great. You want to create your own custom trigger, great. You want to trigger a queue, you want to trigger a job via a queue, great. You have a customizable trigger API that you can handle. It supports saving to a Quartz database and persistence, and typically don't run this in your production app unless your production app is small, because you don't want these jobs clogging down your public-facing site on a bigger applications. If you're small and you can handle some downtime, if you got slammed or something, all right, no big deal. But yeah, others would include maybe the XMPP, so the chat protocols. A couple years ago. This is 2 years ago. They demonstrated in Gemfire. There's the concept of persistent queries. Has anyone heard of this? Where you run a query against a database. So the query could be like find all users where first name is equal to Homer and last name is equal to Simpson. So you'd fire off that query as a persistent query, and it would just sit on the database server and send messages back to you when something was inserted that matched that, right? So I think we're going to see more of that coming from the NoSQL world and the data aggregation, big data movement. Questions?